About this one? This one probably is not going to be that bad. One of the things I mentioned in Sabre Support this morning is, in addition to that list of items that you should be looking at, write everything in terms of sine and cosine, factor if at all possible. One of the things I mentioned is there almost could be another one there that says do whatever you can do. And what I mean by that is, when you take a look at this, I don't see any on the left side. I don't see two fractions that I can put together. Right? Remember, when we're doing a proof, we're dealing with the left side separately from the right side. I don't see on the left side fractions I can put together. I don't see fractions I can put together on the other side. I don't see pieces of recognizable identities. So when I say do what you can do, there is only one path you can take right now, and it's to write the tangents as sine x's over cos x's. So I'm going to do that. And anytime I go through any of these proofs today, everyone, I am not going to be worried about writing the reason for the identity shift or change. So this is 1 plus sine x over cos x over 1 minus sine x over cosine x. And this is going to be a case here where I believe the next step will reveal the solution, will reveal the truth of the proof. Because now although we had only one thing that we could do to begin with, when we did it, now we have something else that we can do and should do. And I think getting rid of the complexity in a fraction trumps everything else. Anytime you have a complex fraction, and what that means in this context, everyone, is within this entire fraction, there are many denominators. I think, algebraically speaking, getting rid of many denominators is always what you want to do. If we had many denominators to begin with, I would recommend getting rid of them to begin with. And I accomplish this by multiplying the top of this expression and the bottom of this expression by cos x. And if you just look at what we're about to write, it will be the left-hand side. So we're going to get cosine x plus sine of x over cosine x minus sine of x. Because, of course, when we multiply that cosine x in, it cancels wherever it can cancel. And I'm going to go back on what I said and say, we don't have to stick to the textbook. You can ask me these questions as well. But you might be prepared for me to answer, to look at a question and go, you know what, let's not worry about this one today. Okay? There's a lesson to be learned out of this example. What starts off looking like quite a complicated task ahead of us becomes simple as long as you don't freeze in the middle of the road, in my analogy. As long as you start trying something, you try a couple of basic things. One is trigonometric, and let's face it, this identity of tangent of x equals sine of x over cos of x is child's play, right? That's obvious. And the other little step is simplifying a complex fraction, and it leads us to the answer. So you would write down here, left side equals right side. And again, at this point, when you wrote down sine x over cos x, you would write quotient identity. Is that okay? Okay, good. Other questions? This one. Okay. Now, they are telling you what to do in 1D. 1D is not a proof. It's saying factor to simplify. But just imagine that this was an identity, that it was equal to something. And you would be asked to prove it. And this was the one we did this morning, right? Okay. So I have a feeling I know why you're asking. I don't think the factoring and canceling is difficult. But then you look at the answer in the back and you go, oh, I must be dreaming. Or I must be looking at the wrong answer because it doesn't seem like the right answer. So what you do is you factor the numerator. You should recognize the numerator as a quadratic expression, that what I would call a basic or simple one, because the coefficient of the quadratic term is 1. So you're looking for two numbers that multiply to give -4 and add to give -3. And that would be -4 and +1. And you factor out the sine of x in the denominator, and you're left with tan of x +1. And by the way, this is a case where I think factoring supersedes writing everything with sine and cosine. And hopefully, when you look at this question, you recognize the numerator as a quadratic, so you would walk down that road. And of course, now we have a factor of tan of x +1 in the numerator, right? It's in brackets, so it's a factor. We have the same factor in the denominator, so you have tan of x -4 over sine of x. And you go, okay, well, that's easy. I got that. And you look in the back, and you're pretty deflated, because what you end up seeing in the back is secant of x -4 cosecant of x. And this is where, when somebody asked this morning in Sabre Support, I said, I'm glad you asked, and I'm pretty sure somebody will ask in class. So sometimes we want to go the other way. Now, what we can do here, Ashley, is write this as tangent of x over sine of x -4 over sine of x. Four over sine of x is 4 cosecant of x. And if we explore tan of x over sine of x, we can write tangent of x as sine of x over cosine of x. And this is over, and I like to make that big fraction, the whole fraction line long, over sine of x. So what you do here is you multiply the numerator and denominator by cosine of x. And what happens, let me write this as well, -4 over sine of x. And what happens, you can cancel a couple of things here, but I would just recommend canceling the cos of x's first to leave you with sine of x on the top over sine x cos x on the bottom. The sine x's cancel, and you're left with 1 over cosine of x. And here you're left with 4 over sine of x. And I hope you see that 4 over sine of x is the same as 4 cosecant of x. And if it's not obvious that you're allowed to say that, then you can write 4 over sine of x as 4 times 1 over sine of x. And 1 over sine of x is cosecant of x. So that's how you get the answer there. And most people look at that question and they kind of discount it and they go, oh, it's just some factoring, I'm not going to do it. But there's something to be learned from it. And we're back to that thing I've talked about before. Trigonometric expressions can have many masks. It's the same thing, but it's disguised differently. Other questions? Yeah.
6.
Give me a number, please.
6 on the...
6? Okay. In the first main section?
Like the one that
Yep. Okay, so I have an asterisk here. This is a complicated one, but we can still learn from it. I'm going to factor this as secant squared of x plus 1 and secant squared of x minus 1. What makes number 6 and some of these in this particular section more complicated is the higher degree exponent. It goes past 2. But secant squared of x is a perfect square, and 1 is a perfect square, so we can factor it as a difference of squares. And this is over tan squared of x. And I have a suspicion, and I have to pick up a formula sheet and look, that there's an identity relating tan squared of x, secant squared of x, and the number 1. So when I look at the Pythagorean identities, it's 1 plus tan squared equals secant squared. So if 1 plus tan squared is equal to secant squared of x, and Cyrus, you're the one who kind of looks at this differently from time to time. I think it's been 3 times you've said, well, can I put this in instead? What we can do is recognize that tan squared of x, which is on the bottom of that left-hand side, is secant squared of x minus 1. That's a huge step. Now, whether we put, everybody, whether we put tan squared of x here to cancel the tan squared of x's, or secant squared of x minus 1 there, we will be able to cancel those factors. I'm going to choose to do this. So I'm going to write this now. This is the left-hand side. It's secant squared of x plus 1. And then I'm going to say times tan squared of x over tan squared of x. Because secant squared of x minus 1 is tan squared of x. Okay, so that cancels. And again, we're not doing a proof officially here. I'm just teaching you would write Pythagorean identity, or you would write down this equation somewhere. So now we're left with secant squared of x plus 1. Well, depending on how you look at it, and I was not going to look at it this way, but if I look at it in the right way, we're just about done. Because what I can do is for secant squared of x, I can put 1 plus tan squared of x. So this is 1 plus tan squared of x. Well, I guess we're not quite done. What do we want it to be equal to? 2 plus tan squared of x. Okay, so I'm not going to take that path. Let's rewrite this in terms of sines and cosines. I thought I discovered a nice quick way to get to the answer, but I didn't. And we're going to put this together now. By putting it together, what I mean is we're going to multiply the top and the bottom of this by cos squared of x. So what I end up with is cos squared of x over cos squared of x. And that leads me to 1 plus cos squared of x all over cos squared of x. Are you okay with that? As I said this morning to a couple people, if we take this path, we're at the end of the road. There's nothing else you can really do with this left-hand side anymore. So it's time to do something to the right-hand side. And the right-hand side is, help me out here, 1 plus 2 tan squared. Two plus 1 tan squared, okay? So 2 plus 1 tan squared. Well, there's nothing really you can do with this. We're back to what I mentioned at the beginning of the class. Sometimes what you do is the only thing you can do. And that's to write everything in terms of sines and cosines. So we have 2 over 1 plus sine squared of x over cos squared of x. And now we're going to multiply the top and the bottom of everything by cos squared of x. I'll do this in steps. Not everything, but the top and the bottom of the 2 over 1 by cos squared of x, so that we can put these things together. So we have 2 cos squared of x plus sine squared of x over cos squared of x. And again, this is on the edge of being something that you would expect to see on an exam. I think it might be on the wrong side of the fence, but we're learning something from it. And I'm really curious. Does anybody see how these two things are going to be equal? I'll give you a hint. 2 cos squared of x is cos squared of x plus cos squared of x. And this is 1. So the top becomes cos squared x plus 1, and it's over cos squared x, and that's what we have on the other side. I mentioned this morning in Sabre support. You know, whether I write, I'll just finish this off, whether I write here cos squared x plus 1 over cos squared x or 1 plus cos squared x over cos of x, doesn't matter. Is that helpful? Okay. Other questions? There are limited options here. And I think just looking at this, I think looking at this, since the bulk of everything on the left and the right is written in terms of sine and cos, why don't we start by writing that secant in terms of cosine? And remember, you're working on the left side and the right side independently from one another. So on the left side, we have secant of x over 1 minus sine of x. And on the right side, we have 1 plus sine of x over cos cubed of x. Armand, do you remember what I said this morning about when you have those conjugates on opposite sides, but one is on the top and one is on the bottom? We're going to probably use what I talked about. Now, I'm going to let everybody in on what Armand and I are referring to in a minute. But I want you to pay attention to the fact that what we have on the bottom of the left and the top of the right are conjugates that if you multiplied together, I guess I'll start revealing what we're talking about now. We're not doing this as part of the proof. I'm trying to teach you something here. Conjugates are things like A plus B and A minus B are conjugates of each other. And what makes them important in algebra is when you multiply conjugates together, you get a difference of squares. All right? And I'm going to explain this, Armand, to everybody else in a slightly different way. So you're getting the benefit of a second explanation here. I said, make note that we have these two conjugates, one on the top, one on the bottom. And whether it's 1 plus sine and 1 minus sine, 1 plus cosine, 1 minus cosine, sine plus 1, sine minus 1, any of those combinations, this is going to be important. If I multiply these two conjugates together, I FOIL it out, my outer will be negative sine x and my inner will be positive sine x, so they're gone. What I am left with is 1 minus sine squared of x, which you should know is cos squared of x. Okay? And cos squared of x is a tidier little thing than a whole bunch of things with pluses and minuses in them. It's a single term. We're going to use that to our advantage at some point. Okay. Now, let's get back to the question. I am going to write this as 1 over cosine of x over 1 minus sine of x. And I'm going to multiply the top and the bottom by cosine of x. Why am I doing this? Because I want to clear this mini denominator of cosine of x that's on the top. James, you had asked about this, right? Okay. So what we get is the following. Now, on the top we get 1. On the bottom, we have 1 minus sine x times cos of x. And I'm about to explain some Math 20 to you, just some math algebra skills with regards to rational expressions. Combined with this, is there a 1 minus sine x on the bottom of the left-hand side? Yes. Is there a 1 minus sine x on the bottom of the other side? No. So that tells me that it is going to be possible at some point for me to cancel the 1 minus sine x. So I'm not going to multiply that bottom out. I'm going to leave it all hanging out there where I can see all of the factors getting ready to be canceled. And I've gone about as far as I can go. If, James, you do multiply this through, I believe later on, you'll just have to factor it again to see what cancels. So now we are about to make use of this piece of information. And you know what I'm telling you? And this is where I went with you this morning. Is this identity is the same as this identity, which is the same as this identity, that original identity is the same as this, which is the same as this, and I wrote that down awfully quickly, but let me walk you through all of them. This requires zero explanation from me, I hope. It's on your formula sheet. This should require zero explanation, but I tend to say, listen, if you just subtract cos squared from both sides, that's what you get. This, up until now, would have required a lot of explanation, but 1 minus cos squared of x is a difference of squares which can be factored into 1 plus cos x, 1 minus cos x. And then what we did in terms of sine and cosine here, we can do in terms of cosine and sine here. So, what I'm going to do is use this final piece of information to make the decision to multiply top and bottom by 1 minus sine of x. Is that my phone? And I'll be back in a minute, but just take a minute and ponder what's going to happen if you expand out the top but not the bottom. And again, everybody, we are talking about not expanding the bottom because I can see on the bottom of my work on the left there's a 1 minus sine of x. I want to prove that these are equal. So I want everything to match. But when I expand out the top, and let's face it, look at the top of this. The top of what I have on the left is just 1. There's nothing there other than 1. So I'd better expand out the top of this. And when I do, I get 1 minus sine squared of x. On the bottom, I have the 1 minus sine of x, which I want. And I have cos cubed of x, which is, well, we won't do that. I have cos cubed of x. And now I can say, James, that the top of this is cos squared of x. And I hope you see that if I had a fraction with a squared on the top and a cubed on the bottom, and whatever else on the bottom, and a squared cancels from the top and the bottom. So what happens here at the top of the screen is I have cos squared of x over cos cubed of x. A cos squared cancels with a cos squared, and I'm left with cos of x in the denominator. Is that okay? Okay. Other questions? So again, I'm in teaching mode here. I'm not even finishing the proof, right? I should be saying 1 over cos x, 1 minus sine x. I should be saying left side equals right side. And all along the way, anytime I use an identity, I really ought to be writing down Pythagorean identity or whatever the name of the identity is I use. I don't think we used the Pythagorean identity here. Oh yeah, we did. Because 1 minus sine squared is cos squared. Other questions? Yep. 5? Looks intimidating, doesn't it? It really does. At some point in my past, I've done most of these, and because I don't have a comment here, it's not that bad. If I turned to one of these questions and I saw this, that'd be a signal to me that this is pretty tricky. Maybe we'll just leave it alone. One of the things, though, that I think is very important is when you take a look at cos to the 4 of x minus sine to the 4 of x, it is a difference of squares. So I'm talking about the left side here. And it factors into cos squared x plus sine squared x times cos squared x minus sine squared x. One of the things I haven't mentioned in general about proofs that I will mention now is, and it almost goes without saying, which is why I haven't really talked about it, is I hope you understand that we are being smart in trying to turn the left side into the right side. If you said, no, you know what, Mr. Way, show me how to turn the right side into the left side, I would just throw up my hands and say, I can't do that. I don't know how to reverse engineer that. Because the right side's simpler, let's take the more complicated side and make it simpler. The reason why this is helpful, and I'm going to go ahead and factor the bottom as a difference of squares as well. The reason why this becomes helpful is because I know that that's 1. And as a factor in a rational expression, 1 is ideal because we don't even have to write it. It's not nothing. It's not 0. It's 1. So this is going to become 1. I don't remember my other Pythagorean identities. But I know there's an identity, I'm pretty sure, that relates 1 tangent squared of x and secant squared of x. I just can't remember. I'm pretty sure it's 1 plus tangent squared of x equals secant squared of x. Is that right, Liberty? Okay. That means that this is secant squared of x. Now, I'm not saying the answer is going to reveal itself right away, but that's a big step forward. What I have then is cos squared of x minus sine squared of x over 1 over cos squared of x times 1 minus sine squared of x over cos squared of x. I'm just shaving a little bit of time off of our work here by making those replacements for cos squared plus sine squared equals 1, and for 1 plus tan squared equals secant squared, and at the same time, instead of writing secant squared, I'm writing 1 over cos squared, and instead of writing the tangent squared, I'm going sine squared over cos squared. You okay with that? Okay. Now we do have a complex fraction, and I love this unit because you get better and better at algebra. I really think that's important. There's always exceptions to what I tell you. I told you that clearing a complex fraction trumps everything. Not if you have denominators you want to get rid of in multiple factors. Because if I multiply top and bottom by cos squared here, it gets tricky in terms of what's happening on the bottom. I think you should expand the bottom out. So we get cos squared of x minus sine squared of x over 1 over cos squared of x minus sine squared of x over cos to the 4 of x. What are we trying to do here? We are trying to turn this, into cos to the 4 of x. So there are a number of ways you could proceed. I think that the textbook and the solution would probably take those two fractions in the denominator and put them together with a single fraction. I'm not going to do that. I'm going to multiply the numerator and denominator by cos to the 4 of x. My motivation there is I want to get rid of the cos squared of x in the denominator of the denominator, and I want to get rid of the cos to the 4 to the x, cos to the 4 of x in the denominator of the denominator. And what I end up with is cos to the 4 of x, and then I have cos squared of x minus sine squared of x on the top. And I want to pause there. Why am I not physically multiplying out that cos to the 4 of x by the other stuff on the top? Because I want to get the whole thing to be equal to cos 4 of x, right? Which means if the whole thing is in fact on the other side equal to cosine to the 4 of x, there ought to be a way to get rid of that cos squared x minus sine squared x. So leave it out there as a factor. And what's going to happen is you're going to get cos squared x minus sine squared x on the bottom. Because when I multiply these together, a cos squared cancels with a cos squared, leaving cosine squared of x. When I multiply, what I should have said here is when I multiply this by this, the cos squareds cancel. When I multiply this, cos to the 4 of x, by this entire thing, all cosines cancel, and I'm left with minus sine squared of x. And again, similar to a previous question, had you multiplied this out in the previous step, then you would just look at it and go, well, I better factor and see what happens, right? On the other hand, sometimes you might look at something and go, you know what, I better multiply it out so I can cancel. It really depends on the situation. Anyway, jackpot, right? And left side equals right side. And again, you would write all of the names of any identities you use along the way. Other questions? Just give you another minute to ponder that. Okay, I suspect I'm not done at the board. I suspect that for the remaining 40 minutes here, 35 minutes of classes you're working on these, you're going to encounter more questions. And I might decide to just help you at your desk, but for the benefit of everybody, sometimes I just go to the board and we go with that strategy. So I'll be walking up and down the rows in a couple minutes. I want to take care of my attendance, and then I'll be checking on you. And don't forget, don't wait for me to get to your desk to ask a question. If you got a question, put your hand up and let me know, right?